and drop a message to all the kids that class has started, so that okay. All right. Okay. All right. What are we going to learn today? Any guess? I have sent you guys a message also in the group saying that we are going to talk about, we'll learn about algebraic identities and understand their importance for solving quadratic equations. And it might sound a little loaded, so we are learning so many things at a very young age. You guys are at a very young age, okay? So quadratic equations and all come more in the level 3, basically SAT preparation. But we are just going to touch upon the basic concept. That would be our focus, okay? Hello, Sundara. Okay. So, first of all, let's try to understand what is algebraic identities. Any idea what exactly it is? Yes, Arif.
The parts of algebra, or how we make it an algebraic identity.
Okay, Advik. So you can sit inside. It's okay.
Can you say the title again?
What do you mean by algebraic identities? What exactly you interpret as algebraic identity? Okay, it's fine. It's a cryptic term that is probably making you worried. Let's not be worried about it. Can I request every child to keep their videos on? Otherwise, it's only Sandhya, Suren, Dikshita and Gitesh keeping their videos on, and everybody. Yeah. I'm sorry?
I'm eating food right now.
Okay, that's fine. So, fine. I mean, as long as you are comfortable. Okay, I'm not trying to force you guys, but yeah, it's better. Now, let's take one more step back. If I tell you guys to tell me, how do you multiply polynomials? Any idea? Arab, you're not the only one talking always. I'll come to you as my last option, Arab, okay? My question to you guys is, how do you multiply polynomials? Anybody? Do you guys know? If nobody says, then I have no choice but to see what Arab says. Yes, Arab.
So if it's like multiplying, like for example, variable a, so then the number next to a you can do 7 times 4. But if it's like a and then another one is b, you can times the numbers and you can also combine the variables.
Sit down. I want to see your entire face. I know your eyes are better than mine, but I want to see you in a right posture. Okay. Let's first decode a lot of cryptic words, polynomials, algebraic, identities, all that fancy terms. Let's forget about them all. Now let's go back to some basics. I said, how do you multiply polynomials? First of all, what is polynomial? Sandrine, Surin, any idea? No? Polynomial? Okay. What is an expression? Gitesh, do you remember? What is an expression?
A thing that doesn't have an equal sign, like a group of numbers and letters that don't have an equal sign.
Yes. Now the one sentence that I will say, which I have said multiple times in different classes, that expression has no outcome. Look at me. If I just come to the class, keep smiling all through. Next 1 hour, if I keep smiling, without doing anything and go. There is no outcome, right? You'll just see me smiling for no good reason. That is what is exactly an expression. When there is no outcome. I mean, I'm not Shah Rukh Khan whom you will come to see, right? I'm just a normal human being. So, my expression has no meaning to it, right? People can still go and see Shah Rukh Khan smiling. There's still a reason for doing so. But seeing me smile has no value in it. Now, you want to get an outcome. That is why you will put an equal to sign. This is an expression. There is no outcome. This is me smiling, okay? That's Shah Rukh Khan. Shah Rukh Khan's smile might have some outcome. Now, I put an equal to sign. I don't want to be compared with Shah Rukh Khan. He's too big a guy. Now this has some meaning to it. Now you guys see a reason why you are spending time with me. Because you see an outcome. You are trying to learn something. There is some takeaway. So this is an equation. If I don't have an equal to sign, this is an expression. That part is clear? I know Shah Rukh Khan and my comparison has no value in it, but at least there is something that you will retain. Yes, Advik.
When you turn the letter right equal 18 balloons came.
Sorry, say that again.
When you turn to write the equation form, it turned into balloons coming out because of the indicated peace signs.
Okay, we'll not talk about things which has no value in it. Ignore that part. If I turn around, balloon comes out, some firecrackers you see, just ignore that. That has no value. That is as good as my expression without any outcome. Now, on serious note, this is x plus 2y is one sample expression. We are calling it expression because there is no outcome. If I have an outcome, this becomes an equation. That part is clear? Now, Dikshita must be wondering from where Shah Rukh Khan came into picture. Okay, let's keep him aside. Now, in this expression, now I have another expression. I have another expression. What is the difference between this expression, this expression, this expression? I know, Arab, you have an answer, just hold it. Advik, you also hold it. Myra, what is the difference between the three expressions that you see on the board? And
I can't read the board at all. My Wi-Fi is not working.
come to the classroom. Just walk downstairs, 20 steps. Okay, Myra, you have to start coming to the classroom. Okay, see, this is a struggle I have as a father. My daughter attends the class from second floor. I'm teaching in the classroom, in the garage. Okay, so coming back to this one, the serious point. Yeah, Dikshita. What is the difference that you see here?
The first one is expression.
Second one?
It just has power 2.
Okay. This one?
I don't know the third one.
Okay. So this is my expression, no value, no outcome. This is Araf's expression, no value, no outcome. This is Myra's expression, no value, no outcome. On a serious note, all these are expressions. The difference that you see here is that they have different number of terms. Now, what is term? Term is the number of things that are separated by these operands. X plus 2y. There is a plus sign which is separating these two. This is one term, this is second term. Now you see there is another plus sign which is separating this guy. This is third term, this is fourth term. So now if you compare, now if you look at this guy and this guy, these three, which I had named as me, Arnav and Myra, the difference here is these are three expressions. This has two terms, one term, two terms. This has three terms. This has four terms. Yeah? Okay? Vasundhara, are you with me, beta? Yeah? I'll just keep checking, okay, so that nobody is missing me when I'm talking through this. So this is an expression because this doesn't have equal to sign. This is also an expression because this doesn't have an equal to sign. This is also an expression which doesn't have equal to sign. The difference between these three is this has two terms, 1 and 2. This has three terms, 1, 2 and 3. This has four terms. Now you will also say, okay, there is a difference in power also. In the situation of an expression, this will still be counted as one term, this will be counted as one term, this will also still be counted as one term, regardless of the power. Okay, you're just counting the plus minus thing in between. Okay, that separates your terms. That's it. Is that okay? Now, Maya, you can hear me okay, right?
Yeah, I can hear you fine, but I can only see your screen as well.
Can you walk down and come to the classroom, please? Nobody in the classroom except it's going to be me and you, okay? Come down. Now, 2 minutes, Maya, I want to see you in the classroom, okay? Now coming back to this one. Here, this is two terms, these are three terms, these are four terms. Now, when I use the term polynomial, polynomial is a term used for differentiating your different expressions. If there is an expression with more than one term, that is called polynomial. So this one has two terms, it's a polynomial. It has three terms, it's a polynomial. It has four terms, it is also a polynomial. If I say x to the power 6, this is not a polynomial, this has only one term. Yeah? Does it make sense? So now when I talk about polynomial multiplication, okay. When I talk about polynomial multiplication, I'm essentially talking about multiplying something like, this is one polynomial, 1 plus 1, two terms. Let's say if I talk about x minus 6, this is another polynomial. This has two terms, this has two terms. I'm talking about multiplying these two. When it comes to multiplying 6 into 5, you guys know that. You know the tables, you can multiply it easy peasy. I'm talking about multiplying polynomials, meaning you have some variables, some constants, some variables, some constants, and you are multiplying them together. If you have to multiply this polynomial with this polynomial, do you guys know how to do it? Do it, Arav. Do it and tell me the answer. Adrik, you also do it.
Didn't we learn this like some time ago?
Doesn't matter. Learning is a continuous process. You learn the same thing over and over again. So I want everybody to give it a try. Try multiplying these two polynomials. Where's your notebook? Get your notebook and pen. Give it a try. Go wrong, that's fun. Going wrong could be a fun activity, okay? Don't worry about it.
Myron finally gets to see you live.
I'm sorry?
Myron gets to finally see you live.
She sees me live for 23 hours in a day. It's just the 1 hour of class he was skipping. That option is exhausted now.
What about school?
Okay, yeah, Gitesh.
For the first polynomial, does it say x plus 2?
Y.
Oh, it's just y. I would see that.
Yeah, no, I can read it for you guys. X plus 2y multiplied by x minus 6. I'm just trying to do it. I want you guys to do it. You guys have 5 minutes to do it. Yadrik, Arav.
I got x squared plus 8x plus 2.
X squared plus
8x plus 2.
Plus 2.
Yeah.
So, our message for everybody is, if you have done something already and you think you did it faster than everybody else, make sure that you review it, okay? Yaritika.
I got x squared minus 6x plus 2xy minus 12y.
One more time, better. X square minus 6x.
Put minus 6x plus 2xy minus 12y.
Okay. Yes, Gitesh, what did you get?
X squared plus 12y.
X square plus
12y.
12y. Okay. Advik, what did you get?
X squared minus 6x plus 2xy minus 12y.
Okay.
That's second option.
Okay. How about you, Dikshita?
I got x squared minus 6x plus 2yx minus 12y.
Okay. How about you, Sandin Surin?
I got y is equal to x squared minus 6x minus 2x minus 12.
Okay. Y equal to. Can you read for me one more time, beta?
Me?
Uh-huh.
X squared, y is equal to x squared minus 6x minus 2x minus 12.
Okay. Yeah. How about you, beta? So, I'm sorry?
Oh, no. Oh, I see.
What happened, beta?
She forgot what she said.
Okay.
Yeah, I realized I did it wrong, and then now I understood.
Okay. Yeah, Advik, you're saying something? Arab, sorry.
I didn't know there was a 2y, so I changed my answer and it's a negative axy.
Negative 8xy. Yeah?
No, it's just axy. That's it. Negative 8xy.
From where did the a come into picture?
I said 8.
Negative 8. Okay. Alright. Yes, Arihan. What did you get?
After everyone already solved the problem, I was looking at the answers and I saw a y. Okay, and I got confused where like the y came from. Like,
There's a
is
y
there
here.
y? That's y. I thought that was 2.
Now, so you have x plus 2y.
Like, I
Yeah.
couldn't see the y.
Okay.
I could only see the 2.
Okay. No, I know there's some reflection from the light also. That's why I'm reading the question for you guys. How about you, Myra? What do you get?
X squared plus 12y.
X square plus 12y. So, I have got different answers and that makes me
You
happy.
will not trust us.
I'm sorry?
You will not trust us.
No. So, see, I trust each one of you, okay? Each one of you as a child. No question about it. When it comes to math, that is when I always instill the idea in your mind that don't trust anybody. That's why I say I don't trust anybody. I am a very normal, natural, organic human being, okay? I trust everybody like the way you guys do. But when it comes to math, I strongly believe in doing it. Now, I want everybody to pay attention to what I'm doing. So that whoever has done it right gets it affirmed. Whoever probably missed it will be able to correct it. Now, when you're talking about, let's see if I talk about 6 into 8. Nothing to worry, 6 times 8 is 48. This is simple. But when you're talking about multiplying something like this, like multiplying this polynomial with this polynomial, let's look at a situation like this. If I have 15 into 4, that is 60, okay? Or let me give an easy one. 11 into 4, 44, okay? Now, you can say this is same as 10 plus 1 into 4. That will be the same value, which will be nothing but 10 into 4 plus 1 into 4. Correct? If you have 4 here, what you are doing? You are multiplying 4 with 1 and you are multiplying 4 with 10 also. And you are getting the same answer. Correct? Same way, if you have a polynomial to deal with, this is 10 plus 1, isn't it? This is 10. This is 1. I mean, I'm saying this is, you can compare that with 10 and 1. That means if I have something to multiply with this first and this first. So meaning, how will I break the bracket open? I will say, okay, fine. This means x into x minus 6 plus this into this plus this into x minus 6. Okay? Or if I want to do it, if I don't want to listen to what Mr. Biren Kumar says, I will say, okay, I will do it differently. I will not multiply this guy with this guy. I will say multiply this guy with this guy, meaning x into x plus 2y, x into this minus 6 into this. Any which way is okay. You can say this into this, meaning this into whole thing minus this into whole thing, or this into this, meaning x into the whole thing and then 2y into the whole thing. Both are okay. Is that part okay with everybody? Ritika, Hiranya, everybody with me, right? Hitesh? Hey, Diwali you have to stop, Advik, Arab. Diwali is 6 months away. Alright, coming back to this one. So, I am saying, okay fine, I am picking up x plus 2y into this. Meaning, first I will multiply this guy with the whole thing plus this guy with the whole thing. So, that is what I will do. X into this thing, x into the whole thing plus 2y into the whole thing. Stop me up if I am doing something which sounds complicated, okay? I am just breaking it like a baby, okay? Fine? Everybody okay? Ritika okay, beta?
Yes, sir.
Okay. And I love babies, that's why I give reference of babies always. So I'm trying to keep it as simple. When I say baby, I'm saying babies are very simple, right? I mean, they don't have anything complicated in life. So I'm saying, okay, fine, I'll do it like a baby. That okay, this into this plus this into this. I'm breaking it open. Now, again, if I have to break this, what does bracket mean? Meaning, this is multiplied by this and then this is multiplied by this. Similarly, this is multiplied by this and this is multiplied by this. That is how I will open it. So, x into x becomes x squared and then x into minus 6 becomes minus 6x. This bracket is open now. How about this guy? This means this to be multiplied by this and then this to be multiplied by this. Yeah? If I have 5 into 11 or 5 into 10 plus 1, how am I breaking it open? I will say, okay, 5 into 10 plus 5 into 1. Same thing I'll do here also. Right? Simple, right? So far? Arihan? Arab's thumbs up is showing a thumbs up on the screen. I will do this and then you'll see a balloon on the screen. Then don't do that. Okay, so coming back to this one. So I'm just breaking the brackets open. So this one I opened saying this multiplied by this and this multiplied by this. So this became, the bracket is broken now. Now I'm breaking this bracket also open. So 2y into x, 2 into y into x, 2xy, whatever you call it. And then 2y into minus 6. So 2 you can multiply with 6 becomes 12 and y remains y. So this became x squared minus 6x plus 2xy minus 12y. That would have been the answer. If somebody missed it, it's not because you are weak in math, it's because you ignored the basic calculation. It's all about practice. Okay? And I want you guys to take out one thing of your mind. That okay, if I make a mistake, somebody will laugh. Nobody in this class is allowed to laugh. You can only laugh at one time, that is when I'm tracking poor dad jokes. No other time. Okay? Alright. So this is about multiplying polynomials. Now, you will say, I was talking about algebraic identities and then I jumped to polynomials and I'm doing all, and then I was saying that will help you solve quadratic equations. There is no relationship here. there is a relationship. And that is why I was saying that knowing how to multiply polynomials is very important. I want you guys to multiply this, and multiply this, and tell me what is the answer for these three. And these three formulas will get glued with you for the rest of your life. A plus b into a plus b, which you can also call as a plus b whole square. A minus b into a minus b, which you also can call as a minus b whole square. A plus b into a minus b. I want you guys to do this multiplication. So this is a polynomial multiplication. This is also a polynomial multiplication. I want you guys to do it and tell me what the formulas are. And those are the formulas which are called algebraic identities that you'll end up memorizing and end up using it for next 15 years. That is my guarantee, at least. I mean, I've been using it for last 35 years now. Why are you doing it? A plus b into a minus b, a minus b into a minus b, a plus b into a minus b. I want you guys to calculate and tell me what did you find. And that will apparently become a formula. These three will become a formula which is called algebraic identities. Yes, Advik.
For the first one, or just like all of them?
All of them. Yes, Dikshita.
The third one, like what's like the second, like the expression?
A plus b into a minus b.
Okay.
So you have three flavors. A plus b into a plus b, which is a plus b whole square. A minus b into a minus b, which is a minus b whole square. And a plus b into a minus b. This is the third flavor. Okay? Derive it and tell me. Yes, Ritika.
Wait, so are we trying to like find like a plus b times a minus?
Yes.
No.
That's the last one. So we are trying to find all the three. A plus b whole square is how much? A minus b whole square is how much? And a plus b into a minus b is how much?
Okay.
Yes. Sandrine and Sulen. You're talking on mute, better. Unmute yourself.
Yeah, so can you like read the last question because I couldn't really see properly.
It's a plus b into a minus b.
Ah, thank you.
And one very stupid question for both of you, beta, okay? Who is Sandrine and who is Sulen? Can you raise your hand?
I'm Sanjay and I'm Sumi.
Okay. I'll try. I mean, it will take me some time to memorize the name, but I'll try not to make mistakes. Yes, Arav.
So I got for the first one, I got a squared plus 2ab plus b squared.
Okay.
For the second one, I got a squared minus 2ab minus b squared.
Minus b squared?
Yeah.
Okay, how
For
about
the
this
third
one?
one, I got a squared minus 2ab minus 2 minus b squared.
Okay.
There's a plus on the a squared plus 2ab.
Here, this way? Okay, yeah, Vasundhara, you were saying something.
For the first one, do I say the first one, second one, and third one?
Yes, please.
For the first one, I got a plus b squared. For the second one, I got a minus b squared. For the third one, I got a squared plus b squared. No, a squared minus b squared.
So, first one you said, what was the beta?
A plus b squared.
A plus b square. No, I don't need a plus b square. I want the breakdown of that. Okay?
Oh, okay.
Yeah.
Okay.
Yes. So all of them, I want you guys to find out the breakdown because that will become a. See, a plus b whole square is nothing but a plus b into a plus b, and I want a breakdown of that. Okay? Yeah. Yeah, Dikshita.
First one I got a squared square plus AB plus BA plus B square. For the second one, I got A squared minus AB plus BA minus B squared.
Okay.
And then for the third one, I got A squared minus BA minus BA minus B squared.
Okay. Yes, Ritika.
So I got, for the first one, I got A squared plus B squared plus 2AB. For the second one, I got A squared minus 2AB plus B squared. And for the third one, I got A squared minus B squared.
Okay. 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 Yeah, Vasundhara. Okay. You're doing calculation. Okay, Advik, what did you get?
I got, for the first one, I got A squared plus 2AB plus B squared. For the second one, I got A squared minus 2AB plus B squared. Yeah, and for the third one, I got A squared minus 2 minus B squared.
Okay. How about yeah, Dikshita, you're saying something. Go ahead.
It's A squared minus AB.
A square minus AB. Which one?
Like the bottom one.
A square minus AB. Okay.
No,
How about
it's like the one you wrote, it's A squared minus AB plus BA minus B squared. The second one.
oh, okay.
No, the first one. Yeah, no, that one. No, like the bottom one.
Okay, the bottom one. This one. This one you said how much? A square.
No, it's like the second one, sir.
Here, this one.
The top one.
This one.
Yeah.
A square plus AB plus BA plus B square. Okay.
Minus B squared.
Minus B square. Okay. Yeah, Rihan.
So for the first one, I got A squared plus 2AB plus B squared. And then for the second one, I got A squared minus 2AB minus B squared.
Okay.
And then for the third one, I got A squared minus B squared.
Okay. Myra, how about you?
For the first one, I got A squared plus 2AB plus B squared. For the second one, I got A squared minus 2AB minus B squared. And for the third one, I got A squared minus B squared.
Okay. Now, I don't want to remember what you all told me. Sandrine, Suren, are you trying that? What was your answer as well? You're talking on mute. You both.
So, for the first one, I got A squared plus 2AB plus B squared. For the second one, I got A squared minus 2AB plus B squared. And for the third one, I got A squared minus B squared.
Okay, how about you, Sandrine?
Same.
Same. Okay, so I am kind of excited to say that I got few answers which are right for all of them. I mean all the three questions. But I don't want to just say that oh, this answer is right. Now, here, when you guys were doing this calculation, okay, I'm sure it's because of oversight. Some of you got a different answer than what it's supposed to be. Let's do it like a baby again. I don't know, babies might get super angry with me. I keep calling out their names over and over again, but I like to do everything like the ways babies do. So A plus B into A plus B. I'm just breaking it down. So that I'm taking this as a base and I'm multiplying with this guy. So A times the whole thing plus B times the whole thing. It became, and now I'm breaking open this one. So A times A square. A times B is AB. I have a plus sign, I'm putting the plus sign. Just be careful with the sign, okay? I have a plus here, nothing here, so that is plus. So I'm opening this one. B times A or BA plus B times B becomes B square. Now look at this. AB or BA. 2 times 4 or 4 times 2 doesn't make a difference. So I will say A square plus AB plus AB plus B square. B into A or A into B is the same thing. So this became A square plus B square and then 1 AB and 1 more AB. So it becomes A square plus 2AB plus B square. This becomes your formula, one of the formula or algebraic identity that you will remember, keep with you forever. A plus B whole square is nothing but A square plus 2AB plus B square. So I'm writing it down in this corner. This is what you guys derived and most of you got the right answer for this one. A plus B whole square equals A square plus 2AB plus B square. This is what you guys found just now. Hiranya, are you with me, beta? Adav, your smile is equally worthy as my expression. No outcome. Okay, all right. Coming back to this one. So one formula is done. A minus B whole square. Again, never be shy when it comes to doing it. Hiranya, are you able to follow me, beta? So far? Okay. Now A minus B into A minus B. That's what we are trying to do. So I will take this into whole thing minus B into whole thing. That is how I'm going to break it. A times A minus B and then I have a minus B times A minus B. Look at this. When I'm doing math, I'm not doing anything fancy. I'm doing it like a story. Like when you narrate, when you watch a movie and then you narrate the story. You know what? This is what happened in the beginning. Then this happened. Then this happened. And this was the conclusion. This was the thing. I broke it into these pieces. And see, you can literally see it like a story, okay? That is how you'll be able to relate it. Now I'm breaking open this guy and then I'll break open this guy. So A times A becomes A square. A times B and I have a minus sign. So A, this is like plus A and this is a minus B. So plus into minus becomes minus AB. Now this is done. I'm going to this guy. Minus B and nothing meaning plus here. So plus into minus gives you a minus again. BA. And then minus into minus gives you a plus. B into B becomes B square. Same thing. A into B or B into A. Same stuff. I will give them one name. So this is AB and this is also AB. B into A or A into B. Same thing. Plus B square. Some of you got a negative in B square. And that is where I want you to be careful. When you are multiplying this guy with this guy, when you don't have a sign, that means you have a plus sign. So minus into plus is always a minus. Meaning if the signs are same, minus into minus gives you a plus. If the signs are same, plus into plus gives you a plus. If the signs are different, you will get a minus. When your signs, when you're multiplying minus with a minus, you get a plus. When you're multiplying plus with a plus, you get a plus. Meaning when your signs are same, you get a plus. When your signs are different, you get a minus. So here, look at this guy. These two have different signs. You get a minus, minus AB. These two have same signs. When you're multiplying them, B into B becomes B square and your sign remains positive. So some of you who got negative, just be careful with that. Now, what does it become? A square, 1AB and one more AB, both negative. So minus 2AB plus B square. This became my second algebraic identity, which says A minus B whole square equals A square minus 2AB plus B square. And if you look at it carefully, what do you observe? A plus B whole square is A square plus 2AB plus B square. A minus B whole square is A square minus 2AB plus B square, meaning A square plus B square is common in both of them. Only thing that changes is this plus becomes minus. When you go look at the difference between A plus B whole square versus A minus B whole square. That is how you have to remember. You just have to remember A square plus 2AB plus B square as a value of A plus B whole square. If you change this to negative, only this 2AB becomes negative. That's it. Is that making sense? I mean, I'm just asking you to relate. See, you don't have to memorize. You guys only derived this, right? We are just looking at how do you relate it so that you don't get confused. Make sense? Arihan? Hinanya?
Yeah, it's making sense.
Yeah. I'm sorry?
It's making sense.
Okay. Alright. Now, the third one was A plus B into A minus B. Nothing different. Same old stuff. It's just a matter of getting your hands dirty. See? This is how I get my hands dirty. What I do, I pick this number, multiply with the whole thing. Pick this one, multiply with the whole thing. That means A into A minus B. And then I have a plus B. So plus B into A minus B. Now I'm breaking open both the brackets one by one. A into A becomes A square. A into minus B. Signs are different. I'll get a minus. A into B is AB. Plus B into A. Both are same sign. So it will remain plus. BA. Minus. Both are different signs. So it will become B into B. B square. Negative of that. Now same thing. A square minus AB plus B into A. Or BA, I can write this as AB as well, minus B square. Now, $2 plus, $2 minus, they cancel out each other. So it became A square minus B square because these two guys killed each other. So A plus B into A minus B gave you A square minus B square. So these are the three formulas which we call as algebraic identities. These are the backbone of algebra and quadratic equations that we'll deal with. Now look at this thing carefully. If you look at this part alone, isn't this a quadratic equation? You have maximum power 2. Yeah? So we will deal with that. We will deal with actually quadratic equation and see how these algebraic identities are actually helping. Yes, Gitesh.
Can you explain the second formula one more time?
Second formula is it? This one?
A square minus 2AB plus B square.
Oh, okay. A minus B whole square. This is the one that we are trying to find out, correct? Yeah?
Yeah.
A minus B whole square is nothing but A minus B into A minus B, right? If I say Biren square, it is Biren into Biren, correct? Same way, A minus B whole square is A minus B into A minus B, okay? Now, here, so when I am breaking, so I have A minus B into A minus B. So this is a simple example of, yep. This is an example of multiplying one polynomial with the other one. So how will I do? It becomes A times A minus B and then minus B times A minus B. Meaning I am multiplying this with the whole thing and then this with the whole thing. That's what I have done here. Now I am opening this bracket. A into A becomes A square. A into B becomes AB. What will be my sign? Negative, because both have different signs. Now this one is done. Now I'm going to this guy. B times A becomes BA, and here I have negative sign, and here I have no sign, meaning a positive. So different signs. It becomes a negative. Again B into B becomes B squared, and here also I have a negative, here also I have a negative. When I have same signs, I put a plus.
Okay.
Yeah?
Yeah.
Remember this thing. Same signs. Multiplication will get you a plus always. Same signs when you multiply, you get a plus. If the signs are different, you put a plus here, this changes. You put a minus here, it changes. If your signs are same, minus and minus, you will get a plus. Plus and plus, you will get a plus. If the signs are different, you always get a minus. Okay? And that plays a very crucial role, because if you did not do it right, you will get a different answer. Okay? So this was minus. So this becomes a squared minus ab, and this also minus. AB and BA are the same thing. A into B or B into A, same thing. So it became a squared, 1ab, one more ab, both negative. So minus 2ab and plus b squared. Yep.
Yeah, I understand.
So these are three formulas which we call as algebraic identities. And I'll just show you guys a glimpse of what these formulas are capable of. Okay. Now if I say I have an equation x squared minus 8x plus 16 equal to 0. I know we have not solved the quadratic equations, okay? And you guys might be thinking, okay, what this guy is up to. I'm just showing you the power of this, okay? I have a quadratic equation and I'm trying to solve it to get the value of x. What are the possible values of x? And I'm just showing you the power, okay? I don't want you guys to get stressed out. This is a 10th grade thing, okay? I will certainly want you guys to spend at least one more year before you get to deal with these problems, okay? But just to give you a feel, we just learned how to multiply polynomials. That is enough for you guys for now. Knowing these formulas is more than enough. This thing you'll deal with in the coming years, but I'm just showing you the feel of it. If I have a quadratic equation like this, what do I see here? X and minus 8x. Oh, this could be related with this formula. Let's see. I have one positive and one negative here. One positive and one negative here. Can I say this is x squared minus 2 into 4 into x, or 2 into x into 4? Same thing, minus 8x plus 16 is nothing but 4 squared. Now, if I consider x equal to a and b equal 4 equal to b, this is nothing but a squared minus 2ab plus b squared. What this equation became? X minus 4 squared. Yeah? That means x minus 4 equals 0. That is x equal to 4. So since we knew this formula, we are able to use that for solving a quadratic equation for the value of x. I know this is loaded. You guys will call it this is deep. Yeah, that's what you say. This is not very deep, or this is deep. So this might look deep for now. Let's not get lost in the depth of this problem for now. But what you have to remember is that these algebraic identities become a backbone for solving quadratic equations once you guys grow a little older. Ritika, do you agree?
Sure.
Yeah, okay. No, I'm just checking if anybody has encountered with this, okay? Yes, Gitesh.
I've learned this before.
Yeah. Gitesh, you have raised your hand. Tell me.
How do you get x minus 4 squared equal? Yeah, how do you turn x squared minus 2x No, 2 into
I'm just
x.
creating, see this becomes my formula. Like 4 times 8 is 32. This is a table, right? Here, what I'm doing is, I have an equation like this. See, what is A and B here? A and B are variables. Today A's value could be 5 and B's value could be 8. Okay, let's look at it. Let me give you guys more interesting problem than making you guys scratch your head and lose hair like me. Come here. If I say 12 minus 18 square, okay? Now 12 minus 18 square is how much? 12 minus 18 is how much? Minus 6 square will be how much? 36. Fine. Now I will put A equal to 12 and B equal to 18 and see what happens. And use this formula. Huh? If I put A equal to 12, see this is A, this is B, A minus B whole square. If I put this in this formula, what happens? Do I get the same value or not? So what I'm doing is, I'll use A equal to 12 and B equal to 18. And put in this formula. What it says? A minus B whole square equal to A square minus 2AB plus B square. So A square, that is 12 square, minus 2AB. So 2 into A is 12, into B is 18, plus B square, that is 18 square. So here 12 square is 144, and this is 12 2 is 24 into 18, 24 into 18, 18 4 is 72, 18 2 is 36 plus 7, 43, 432 plus 18 square, 18 square, 18 8 is 150, 144 and 180. So this becomes 4, 12, 3, 324. So this is 144 plus 324 is 8, 6, 4 minus 432. This is 36. So, see, what I'm trying to say here, whatever I did was an utter nonsense, trust me. This is not needed. Okay? But what was the message for you guys was that A and B are just two variables. And it could become anything. A could be 10, B could be 5, A could be X, B could be Y, A could be 9, B could be Z, and you can use this formula for solving it. And that is exactly what I did when I was trying to relate this guy. I could see that this is my A square, this is my B square, I mean 4 square. My A is X, B is 4. Is it 2 times A, which is X, and B, which is 4? I could relate it with the generic 3 formulas that we have derived, which is called algebraic identities. And this might look complicated for now, okay? Don't stress yourself. I'm just saying that as long as you know how this formula came into existence, as long as you know what is polynomial, as long as you know how to multiply polynomials, you are still good. You are way ahead of where you want to be. And when we try solving quadratic equation, that is when we will make our life a little more complicated. Sandrine Sulin scratching her head. Advik, Arav has hidden his face now. He doesn't want to show his reaction to me. Advik, stressed out? Dikshita is thinking what to do. No? Okay. So again, so these are the building blocks, okay? I started with who all knows how to multiply polynomials? Who all knows how to use algebraic identities? These are cryptic sounding words, but when it comes to breaking it down to simpler things, it becomes much more amiable than just going by the the phonetics part of it. Okay, make sense? I don't take pride in getting you guys stressed out. I'm just saying that these are the building blocks that we will use in future. And again, just a message for you all that we are going to start revising all the concepts from 6th to 8th grade from 4th week of May. Meaning all the things that we have learned, we will revise it one more time. So the concepts related to 6th and 7th grade, the ones that are simpler, we will deal with more of the word problems so that those are, it's okay, beta, that's fine. So I'm saying, so when we start, we will start the entire syllabus one more time from last week of May, and in next 6 months we'll try to cover all the concepts one more round. And kids who are in 8th grade, after 3-4 months, or kids who are going to 8th grade, after 3-4 months, they will be ready to go to level 3. Kids who are already going to 9th grade, they'll be jumping into level 3 from 4th week of the month May. Okay, so that way they start in the level 3 is for 9th to 11th grade. So that's what it will be. Out of stop your emotions. Those emotions have no equal to sign, so no outcome for me. Okay. All right. So coming back to a serious point, all that we are doing right now, these are like some of the building blocks that we are just catching up on. It might look little complicated, but again, in 2-3 weeks from now, when we do the second cycle of the entire syllabus, some of you will know why we are learning these things and how it is relatable. Some of you who will move to level 3 soon. Ritika, you are going to 9th grade, right?
Yeah.
Yeah. So Ritika is one who's moving to level 3. Sandy and Sulain, you guys are going to 8th grade this year, correct?
We're going to 7th grade.
Yeah,
because we're going to CBE in the summer.
Okay. So then obviously you guys don't have to rush for level 3 for sure. So it's only Ritika in this group who will move to level 3 in 3 weeks or 2 weeks actually. Rest all will continue in this group and we'll do second iteration. And probably when you see the concepts for 6th, 7th and 8th grade one more time, it will make you more prepared, more thorough with what you have already learned or known before. Something that goes missing, you'll be able to revise that. Anybody in the class who is going to 9th grade apart from Ritika? Hiranya got dropped off. Vasundhara, how about you, beta? I'm sorry, beta. Say that again.
I'm going to 8th grade.
8th grade. So you still have time. So for you, for people like Vasundhara who are in 8th grade, what we'll do is we'll start the second iteration of the entire syllabus from the 4th week of May. We'll do that in next 4 or 5 months, and then I and Vasundhara will have a one-on-one talk to see if she wants to move on to level 3 or she wants to spend few more months in level 2, and along with her parents also. Okay, so that way we'll make sure that we are making the right decision and then putting the right effort and energy in the right place. Alright, with that being said, it's already 5 o'clock. I will let you guys go unless you want to spend half an hour more with me. There's no reason for that. Enjoy the rest of your evening. We'll meet again tomorrow same time. Alright?
Bye, sir.
Bye-bye, 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 bye-bye.
Sir?
Yep.